Hello, everybody. It's your tutor here, and we are going to briefly go over the concept of number systems and how to convert between them. Reason why this is important is because when you're working in the world of computers, computers don't speak decimal like humans do. Computers speak binary, ones and zeros. But the system that we are the most comfortable with has to do with the number 10, base 10, which is our decimal system. So before I go ahead and show you how to convert, let's just talk about the concept of what a number system actually is. And it's easy. So let's go back to probably a fourth or fifth grade problem where the teacher would ask you, okay, take this number and write it in its expanded form. So if you don't know exactly what that means, all it means is take the number that you have and then break it up into its pieces. Break it up into its ones, its tens, its 100s, it's 1,000s, it's 10,000s, and so on. You get the idea. So 2,130 is the same as 2,000s plus 100 plus 3 tens plus 0 ones. So that's the way that we write it out in words. But how do we write it out mathematically? Well, we have to know the base that we're using, we have to know what our digits are, and we also have to know what position our digits are in. And this goes for any number system. So we start at position 0, which is on the right, and then we go 1, 2, 3, and however much more that you need. In this case, there are 4 positions, 0 through 3, so we go ahead and our 2 is in the third position, so that would be 2 times our base, which is 10, to the third, plus 1 times 10 squared, plus 3 times 10 to the first, plus 0 times 10 to the 0, which is in fact, down below, 2,000, because 10 cubes is 1,000, times 2 is 2,000, plus 100, plus 30, plus 0 is in fact 2,130. So that's a review on expanded form. And this is the idea that you're going to be using when you're working in a system such as binary. So let's say that we have a number here in binary, and I'm denoting that it's in binary with my subscript, the 2, which represents base 2. I want to know what 1101 in base 2 is equal to in base 10. We're going to use the same exact idea that I just showed you above. We are going to write out its mathematical expanded form, and we're just going to sum up the individual pieces. Nothing too tricky. So the positions are exactly the same. We've got 0, 1, 2, 3, but the only digits that we're working with are 1 and 0, which makes the multiplication easy. So let's go ahead and start. So we have 1 times our new base, which is 2, and that's going to be raised to the third, plus 1 times 2 squared, plus 0 times 2 to the first, plus 1 times 2 to the 0, which is equal to 8, plus 4, plus 0, plus 1, which is equal to 13. So as you can see, nothing too terribly complicated here. So we now know how to go from binary to decimal. We actually know how to go from any number system to decimal. You just take your digit times your base raised to the power of what position that digit is in. And then if you sum up all those pieces, you will get to your decimal form. But let's say we want to go the other way. Let's say that we already knew that we were working with 13 in the decimal system, and then we wanted to get back to its binary result of 1101. How do we do that? What I've done here is I've written down the steps to success in order to achieve this task for any number system. So let me read the steps and then I'll walk you through it. So step number 1 will be just start with your decimal number, of course. And then step number 2 is going to be divide your decimal number by the base of the system that you want to convert to. In this case, we're going to be using 2. And then you want to record both the whole number and the remainder. And then you're going to repeat this process until the whole number part is 0, and that's when you know to stop. So let's go ahead and apply these steps. So if we've got 13, and we want to go to binary, so the base is going to be 2 of the system that we're going to, so we're going to divide by 2. So we want to divide by 2, 13 divided by 2 is 6, with a remainder of 1. 6 divided by 2 is 3 with a remainder of 0. 3 divided by 2 is 1 with a remainder of 1. And 1 divided by 2 is 0 with a remainder of 1. So we're all done with this loop. So now what I'm going to go ahead and do is circle these numbers right here. Reason why recording the remainder is important is because that's going to be the digits that you use in that system that you converted to. And you're going to read these from the bottom to the top. So from the bottom to the top, I'm going to be writing this from the left to the right is going to be 1, 1, 0, 1, which is in fact the result that we have above. So we know that we've done this right, so it's really easy to check your work. But just to show you that this system works for any number system, let's go ahead and take the number, erase this first. Let's go ahead and take the number 31. And we are going to say that this number is in base 10. And I want to know what this is in base 3. We're going to do the same thing. So start with your decimal number. That's step 1. So I'm going to do that over here. And step 2 would be to divide by the base of the system that you want to convert to. This time we're going to be dividing it by 3. So how many times does 3 go into 31? It goes in 10 times with 1 left over. Then you can see the pattern here. Go ahead and finish up this problem, pause the video, and then we'll come back and compare results. Alright, so what you should have gotten when you keep dividing, 10 divided by 3 is 3 with a remainder of 1. 3 divided by 3 is 1 with a remainder of 0, and 1 divided by 3 is 0 with a remainder of 1. So if I go ahead and circle these numbers, read it from the bottom to the top, and write it from the right to the left, the left to the right, sorry, you're going to have 1, 0, 1, 1. Let's go ahead and check our result, though, to see that we're right. So converting this to decimal system, just to make sure that we have 31, you're going to go 1 times 3, in this case, because that's the base we're working with. 0, 1, 2, 3, that's in the third position, plus 0 times 3 squared, plus 1 times 3 to the first, plus 1 times 3 to the 0. That's going to equal to 27 plus 0 plus 3 plus 1, which is in fact 31. So there you go. That's pretty much all the tools that you're going to need to convert between number systems. There are some trickier examples that Kira is going to walk you through. There's like examples involving decimal points and then converting between that when you're using floats. But it's a bit trickier, but it's mostly the same process, but Kira will show you that. And in the next video, I'm going to show you a special trick to convert straight from binary to hexadecimal. And I recommend that you watch that video. The reason why is because when you start writing programs during your lab time, the environment that you're working in, when you look at that register window and then you see what the values are, you're actually looking at hexadecimal values. But the thing is, a lot of the questions that you're going to get are going to ask you about binary numbers. So your ability to convert between those two systems in the snap of a finger is going to be really beneficial to you both during tests and during the labs. So, hope you enjoyed this soft introduction to number systems, and I'll see you on the next video.